Hello everyone. Today I'm looking at the container with the most water. And you can see the function they give us is called max area. So if you're concerned about water and containers, just remember what you're really doing here is looking for the max area. And to determine the area, you multiply the width times the height. So you're going to pick two numbers in this array. The correct answer here is 8 and 7. And so between this red line and this red line, you can create an area determined by the width and height. And so just by looking at this square, you can see some things. So notice between the two red lines, we are only concerned with the smaller of the two. Because if you tried to fill this up with water up to the 8 number, it would spill over the smaller one. So we can only say our height is as tall as the smaller of the two walls containing our water. So from there, you have to choose two of these numbers, and you can do that with a pointer. So you might have a pointer pointing at this end and a pointer pointing at this end, and you'll move the smaller of the two pointer and then determine the area. So at first it's 1 and 7, and you see 1, and so the height is the smaller of the two, so 1, and then the width is right minus left. So but the index, right? So you have 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 0 is 8. So 8 times 1 is 8. So you can write that down. You can store it in a variable and say 8 is your max. But then you move the pointer of the smaller one, and you find 8 for a height value. And then you do the calculations again, and you see, oh, well, the smaller of the two is 7. So 9 minus, let's see, 8, the last index is 8. So 8 minus 1 is 7. So 7 times a height of 7 is 49. So what we must do is define a left pointer to be 0 and a right pointer to be the last index of the given array. And then we're going to have a max water variable. So each time we will calculate the max water, and we don't need to worry about stopping our pointers until they're basically touching each other. The thing that will update is the max water. So once you find a max, you don't need to worry about updating it with a lower max, because it will only be updated if the new area you find is greater than the area you've currently stored. So let's go ahead and keep on with this 2-pointer solution. So the condition for moving pointers on the left and right side towards each other is while left is less than right. And so we're only going to move the smaller of the two. So height of left is less than height of right. So in the case that our left pointer, in this case 1, is smaller than our right pointer, which is pointing at 7, then we want to move the left pointer. And the only other possibility is that the right pointer is smaller. So in that case, we would move the right pointer. Now that we've handled the pointers, we need to determine the area. Now, area is equal to width times height. Now, the width is going to be the right pointer minus the left pointer. So the right pointer is the index. We're talking about indexes. So the index of the last element is 8 minus 0. And that can, as we move these closer to each other, that will change invariably. So that will change. And then the height is going to be the smaller of the two. So to determine the smaller of the two, you can say math.min, and it's either going to be height of left or it's going to be height of right. It's either going to be the right height or the left height. And so in this case, it is multiplied by, in the first case, it would be multiplied by 1. And so there you have it. 1 times 8 is an area of 8. But if you move the pointer, the left pointer, because it's smaller, you get 8 and 7. The smaller of the two is 7. The difference in the index, which is the width, is 8 minus 1 is 7. So 7 times 7 is 49. And so we want to store the value in max water. So max water is going to be the bigger of the two. So math.max, it's either the current or the area you just calculated. So this is going to be a binary decision, just like this was a binary decision. And just like this was a binary decision. So we have like a bunch of different solutions, different decisions that we're making here to find the area, the max area. Okay, everyone.